Hello and welcome to SudoKanard. Yes, we're here to solve this position sum Sudoku by Richard Stolk from the Netherlands. This was intended for the German Sudoku Championship in 2024, or Deutsche Sudoku Meisterschaft. But Richard says that the puzzle was considered too difficult for the competition, so he published it as a standalone puzzle on Logic Masters Deutschland. And the rules of position sums is that the first two digits in a row or a column are called A and B. So those are A and B, and this is the sum A plus B. So 13 is the sum of those two digits, 15 is the sum of those two digits. And then we have the eighth digit plus the bth digit, which means that, let's say those are 6 and 7, then the digits in 6th and 7th position sum to 9. This is what this rule set says, and you can see that there are very few clues and in very symmetrical positions. So let's start with the easy part. 4 can only be the sum of 1 and 3. 17 can only be the sum of 8 and 9. So the digits in 8th, 8th and 9th positions are 1 and 2, summing to 3. So they are here. Well, and the digits in third and first position sum to 10. So this plus that is 10. It can't be 1 plus 9 because of this, so it has to be 3 plus 7. And now those two digits summing to 15 don't include a 5, so they must be 6 and 9. And digits in 6th and 9th position sum to 8 without using 6 or 7, so they must be 3 plus 5, so 5 here and 3 there. Those are 2, 4, and 6 is not here. Here we have digits from 1 to 4 and 8, but I don't think we can do much about this. But 6 and 9 here, to achieve this 13 sum, those must be 5 and 8. So that this plus that is 9 without using those digits. They can still be 2 plus 7 or 3 plus 6. So that was a very nice start. This is now from 1, 2, and 4, and 8 is somewhere in here. Where is the next place to look? Here we have 15, here we have 12. If this is 6 and 9, then it means that this digit is part of the 11. Oh, and that doesn't work. If I try to make this 15 be 6 plus 9, then this plus that must be 11, which can only be achieved by 2 plus 9, and that is impossible. So that those two digits are 7 and 8, and those two digits sum to 11 without using 7, 8, or 2, so they must be 5 and 6. 5 here, 6 there. And now this 12th clue without using those digits must be 3 plus 9. So this plus that must be 8 without using 3. So it won't be 2 plus 6, it will only be 7 plus 1. This is not 1, those are 1 and 8. Here we need 3, 4, 8, and 9, but those are not 3 and 9, and this is not 4. So 3 is here, 9 is there, and here we have 2, 5, and 6. By the way, now 5 and 8, here and there, must sum to 9, and I said earlier that they must be either 2 plus 7 or 3 plus 6, which means that this is 2 or 6, this is 3 or 7. And 9 must be somewhere, actually, no, sorry about that. So there are 3 and 9 here. Those are from 2, 4, 5, and 6. So those are from 2, 4, and 6, which makes a 2, 4, 6 triple. 3, 7, and 9 are all in here. Now this 5 sum can't include a 3, so it must be 1 plus 4. But 1 here would mean that this would have to be 11. So that wouldn't work. This is 4, this is 1. We must sum the first and the fourth, which means they must sum to 12, so that this is 8. And that's it. Here we need 2, 5, 6, and 8, but I don't think I can do anything with that amount of information. I can do Sudoku, however, and put a 1 here. Those are from 2, 3, 4, and 7. So this is from 2, 4, 7. I won't pencil mark anything more in this area. That's not a 6 because of that. 6 in the column is here. Those are from 2, 4, and 5. So this is 2 or 5. 2, 4, 5. I need a 7 and an 8 somewhere here. And because of that, 8 is there. Those are from 1, 2, 4, 7s. No, 2 is not here. So those are from 1, 2, and 7. And 4. No, from 1, 4, and 7, sorry. 4, 7, 1, 4, 7. This is 2, 5, and 8. 8 is not here. Those are 3, 6, and 4. That's not 4. Those are 1, 7, and 9. This is not 1. And I can only imagine that this is where the hot part happens. So an interesting point here is that none of those are 3s because of this. So we don't use this digit to provide the 6. So the sum of 6 is 2 plus 4. And they are in positions that sum to 11. So this is where the fun begins. 2 and 4. Where can 2 and 4 be? Oh, either one of them is here, which would mean that this is the 2, or they are both in here. If they are both in here, then they are in positions 5 and 6, which means that those are 5 and 6, and those are 2 and 4, and then there's no option for this cell. So 11 is not with 5 and 6. Could it be 4 and 7? No. So it can only be 2 and 9, with 2 being in second position and 4 being in ninth position. That works. Beautiful. And it resolves a lot. And now this is 4. This is 2. And this is 2 as well. That's not a 2, and we're left here with 3, 5, and 6. Here, those are 3 and 9. So 3 here, sorry about that. 3 is here, that is 9. Now, What are we looking at? This 5 or this 7? I can pencil mark 3 and 7 here. So what about this? Those are digits from 4, 5, 6, 7, which means those positions. We need 2 digits in those positions summing to 7. They can't use the 3, so they must be either 2 plus 5 or 1 plus 6. And the interesting part is that we know in which positions. What option, or do we? I think I'll have a look at this one. Here, those are from 2, 5, 6, and 8. Those are not 2s, those are not 5s. And those are positions of digits summing to 5, which means either 2 plus 3 or 1 plus 4. And how do we achieve this? I'm not sure this is really the easy part. I just hope I didn't overlook anything with those double clues, but I think that's okay. So perhaps 7 is more promising at this point rather than 5. I'm saying that 2 will never work. 2 here doesn't work. This is correct because this would be part of a sum of a pair summing to 5. That's not possible. So 2 is here. So now there's one digit here or there, and the other digit. So those are the digits. So they can't be 2 plus 3 because of the 3. So they must be 1 and 4. So 1 and 4 must be on those positions, which means that this is not 4, this is 4. So we get 1 and 4 in those positions. So 4 is somewhere here. And 1 is somewhere here. I don't think I can do better at this point. So let's have a look at this 7. As I said earlier, this 7 sum must be either 1 plus 6 or 2 plus 5. Which does pretty much look like a nightmare. Oh, but I've been overlooking something here. This is 8, this is 9, this is 5, this is 8. So this is not 5. And this is not 7. This is also from 4, 5, 6. This is also from 4, 6, 7. That may look like very little progress, but any little bit of progress has to be used. So I think this is the part that prompted the decision to not use the puzzle in the contest. So an interesting point is that if 4 is here, which means that this is 5, if I put a 5 here and I use the 4 there, then there will be a 4 here, which means that this will be part of the pair summing to 7. But that's not saying so much. If I'm trying 6 and 8, then this will be 4 and this will be 1, in which case there is no 6 in here. I don't think I can find any other way than just bifurcating. Oh, I've been missing something again. This is 7, this is 2. Oops, what am I doing? No, sorry, this is 3 and 7. So I can't do any better than that at this point. And I really need to try something. I'm afraid I have to try something. Oh, no. There is a quadruple. That has to be useful. We need the 3, 5, 6, and 8 to fill in those cells. So that can't be a 3, that can't be a 5. 1, 2, 4, 7, 8. No. And this can't be an 8. Yes. 8 is in one of 4 positions. So probably no bifurcation after all. So this can't be 8. This has to be 2. This is 5. This is 8. So this is not 8. Is that all? I still need a 2 somewhere in here. So those are from 1, 4, 7, 9. Right, so this is from 4, 7, 9. This is from 1, 4, and 7. And there is an 8 in here. That's the important fact. There's an 8 in here. So this must be part of the 5 sum. So this has to be the 1. And the 4 is either here or there. And this is either 4 or 7, none of which can be part of this 7 clue. So that this is not part of the 7 clue, so none of them here is a 6. And we get a 4, 7 pair, so that this is 5, which means that this digit is part of the 7 sum, and 5 is not. So this is 1 plus 6, 1 or 6 here, and the other digit is either here or there. And by the way, that's not a 5 because of this. And 1 can only be here in the column. So we're looking for the place of 6, which could be here with a 7 there. By the way, that's not a 5. And if this is a 4, then 6 is here. And this is actually from 2 and 6. It's not over yet, but so should just grind the bifurcation? Should I just bash through the possibilities? If I put a 6, if I try 6 and 8, something tells me that 6 and 8, just by uniqueness, is not something we should consider, because with 6 and 8 here, nothing will be disambiguated there, and that should point to the fact that this should be a 5. But I won't use uniqueness arguments. So if I try 6 and 8 here, this points to this being impossible. If I try 6 and 8 here, then it means that 4 is there, so that this is 7. Well, let's just try. Let's just commit to this, and I just backtrack later. And this is 3, this is 6, this is 2, and this is 4, and this is 7, and this is 6, which seems to work. It seems to work. 6 and 8 with 4 and 1, they work for this part. But where it stops to work is here. This is 5, and this has no option anymore. So that is very much bifurcated, I'm afraid. But that works. So this has to be a 5 finally, which makes this a 6, this 8, and it will disambiguate all of that. So that's now the 5 and 8. So it means that 4 is here finally. That is 7, that is 4, which means that this is 6. 4 and 5, those sum to 7. So that's a 3, that's a 6. This is working. 3 here, 9 there. 7 and 3. That's a 5. 6, 5 and 2. 6, 7, 6 and 4, 9 and 7 here, 2 here, and 9 there. Well, that's, I agree with not choosing this puzzle for the championship. This part was really, really foggy, I must say. Perhaps I just overlooked a simpler argument. And on paper, I would have just tested very quickly the possibilities, actually, and this would have been not so bad, I think. Actually, I wanted to find a better argument for just finishing the solve. Anyway, thanks for watching this video, and see you someday on SudoKanard.